Howdy, howdy. This is Mr. Potter. Welcome to day 10 of our logic series. Today we're going to be talking about Modus Ponens, Modus Tollens, and Hypothetical Syllogism. These are three arguments that are so prevalent in logic that they have their own names. And we're going to have to learn how to recognize them in the arguments that we see in class. So we're going to start by talking about modus ponens. Modus ponens is P conditional Q, conjunction P implies Q. In other words, if I have a conditional and I know that the antecedent is true, then the consequent must also be true. And so we can prove this using a truth table. Remember, of course, before we can do that, we have to rewrite this as a conditional. And ask the question, is it a tautology? So we have two statements, P and Q. We want to investigate P conditional Q, which we're familiar with already as being true, false, true, true. Only false when the antecedent is true and the consequent is false. And we want to take a look at the conjunction with P. Of course, the conjunction is only true when both statements are true, and that only happens on the first row. With this being our antecedent and Q being our consequent, we know that the condition is only false if the antecedent is true and the consequent is false, but that never happens. And so what we end up with is a tautology. And a valid argument. So we've proven through truth tables that this argument will always end up giving us a tautology. In other words, this is always a valid argument. What we have to be worried about, though, is the fact that our arguments will not always involve the letters P and Q. I could have B conditional Y and B implies Y. What's important is that the antecedent has to be the statement that's being anded, has to be the statement that we're adding with the conjunction. And our consequent should be our conclusion, our therefore. for statement. So I could even have something like negation A conditional F and negation A implication F. As long as this matches this and this consequent matches our conclusion, this is the modus ponens style of argument. So I could even have something as confusing as negation X conditional negation G and negation X implies negation G. As long as our antecedent matches this conjunction term and this consequent matches our conclusion, we have a modus ponens style argument. And at the end of the video, we'll talk about how these actually look in modern English. But modus ponens is the first argument that we encounter. The second one is modus tollens. It's got a very, very similar name, but it's quite different. We still have the conditional at the front, but instead we're looking at the negation of our consequent as being our second premise. And the negation of our antecedent ends up being our conclusion. Now again, I want to prove that this is a valid argument, so we're going to start by looking at it from a truth table standpoint, which means I need to rewrite this implication as a conditional and add those little words. Is it a tautology? So we're going to need to do a truth table to prove the validity of this argument. And I'm interested in negation P and negation Q. These were statements we didn't have in the previous argument, but those are pretty easy to work out. And I'm interested in P conditional Q, which we're quite used to at this point. It's true, false, true, true. But I want to conjunct it with negation Q. And so I'm going to compare the fifth column with the fourth column using a conjunction. A conjunction is a statement that is only true if both statements are true, and that only happens in the fourth row. Everywhere else is false, but this is my antecedent, and negation P is my consequent. So when I do my final comparison, my final conditional, I'm looking for a statement where my antecedent is true and my consequent is false, which just doesn't exist. So we do end up with a tautology. And so this is a valid argument. And again, as we spoke about with Modus Ponens, it's not just enough to have memorized this equation, but we really need to understand the form that we've got here. If I have D conditional R, this second premise needs to be the negation of my consequent. This would need to be negation R for this to be a Modus Tollens argument. And similarly, my conclusion has to be the negation of my antecedent. It would have to be negation D. What's important is that this has to be the negation of my conclusion, and this needs to be the negation of my second premise. And as we stated before, negations are statements. So if I had something like negation in conditional negation Q, and the opposite of negation Q would be a regular Q. And this should imply the negation of my antecedent will the negation of negation in by the property of double negation is just n. Again, what's important is that these have to be negations of each other, as do these terms. So we have Modus Ponens, which uses the antecedent as its second premise. We have Modus Tollens, which uses the consequent, the negation of the consequent, as its second premise. And the third argument we're going to be talking about is hypothetical syllogism. It's a very, very long name, and what's different between what we've done with hypothetical syllogisms, or what we've done with the other arguments, is that we actually do have two different conditionals. In other words, our second premise is another conditional. And because we end up with three different statements, our truth table has to have those three statements. So our truth table must be 8 rows. So again, my first step in proving this argument is to rewrite this as a conditional. So I've got P conditional Q, Q conditional R, and I want to change this to a conditional of the argument P conditional R, and I want to add those words is a tautology. But when I'm doing this truth table, I've got P, Q, and R. And because I have 8 rows, 2 times 2 times 2 is 8. Half of 2 is 4. Half of 4 is 2. And half of 2 is 1. And so this gets the start of our truth table down. Now we need to do our parentheses. So we have P conditional Q. And of course, it's only going to be false when the antecedent is true and the consequent is false. So only in the 3rd row and the 4th row. I've got Q conditional R. Which is also only false when the antecedent is true and the consequent is false. But that happens on the 2nd and 6th row. So I've got true, false, true, 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 false, true, true. And I've got P conditional R. So that's going to be true, false, true, false, true, 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 true. And this allows me to complete my argument here. I need to do the conjunction of these 2 parentheses. So I've got the first parentheses conjunction, the second parentheses. And so I'm comparing the 4th column and 5th column. Only true when both statements are true. So 2nd, 3rd, 4th, and 6th rows are not. The 1st row, the 5th row, the 6th row, or the 7th row, and the 8th row. And with this being my antecedent, and this being my consequent, I'm looking for trues in this column and falses in this column. And again, this just doesn't happen. So what we notice about this last column is that we actually have 8 trues. So this is a tautology. And this is valid. So what's different here is that for our hypothetical syllogism, I've got another conditional involved for premise. And my conclusion is also a conditional. So that makes this probably one of the easiest ones to identify. But what's really important for us is that this term here, the consequent of the first conditional, must match exactly the antecedent of the second conditional. And because these letters match, these letters don't show up in our conclusion. What shows up in our conclusion is our first antecedent and our second consequent. And so we need to recognize hypothetical syllogism by the fact that these letters do have to match. And as long as they do have to match, then this should match, and this should match. So I can have something like R conditional F and F conditional J. And this would have to imply R conditional J. Notice that my innermost letters match the antecedent of my second conditional, matches the consequent of the first conditional. And the very first antecedent is my new antecedent. My very last consequent is my last consequent. I always have to have the letters matching in this order. It's essential. There's one other argument that we want to talk about today. This is really more from our textbook, and we're going to be using it later on in lessons. This theorem 8a, it's actually a very simple concept, but it's one of those situations where it's so simple that it looks difficult. I've got P conjunction Q conditional P. Okay, remember that we do want to write this as a conditional. If we want to prove this using truth tables. So I've got a statement P and Q. And the conjunction is only true if both statements are true, which only happens in the first row. And when I start looking for parentheses conditional P, with this being my antecedent and P being my consequent, I don't end up with any true falses. So I do end up with is a tautology. And so I do have a valid argument. What's really more interesting is looking at this from an English standpoint. So I could say something like, my eyes are green, and Sam has 2 cats. Therefore, my eyes are green. What I've really got here is the fact that I do care about. And then this other fact, which really doesn't matter in the grand scheme of things. I've got my eyes are green, and this could be anything. Because what I'm trying to conclude is this first fact, which I already know is true. Because a conjunction is a statement that is only true if 2 given statements are true. My eyes are green, and Fred has $1 million. My eyes are green, and the sky is purple. It really doesn't matter what this second statement is, because I'm trying to conclude the first statement is true. And so this is the theorem 8a, and we'll be talking more about this in later classes, probably around day 12 or day 13. So to recap, we have 3 different arguments here. And these are the 3 different arguments that we talked about being named arguments. So notice what I've got here. I've got, if Fred eats 10 apples, then he will get sick. So I've got a conditional. Fred eats 10 apples, and he gets sick. Fred ate 10 apples, so that's E, because he's eating them. Therefore, Fred got sick. So I have a premise, E conditional S, and my second premise is my antecedent, therefore is my implication. And so what I notice here is that this is our Modus Ponens argument, because my antecedent is the second premise. My consequent is the conclusion. Here I've got, if Fred eats 10 apples, then he will get sick. That's the exact same conditional. But now I'm saying Fred didn't get sick. So that's the negation of S. And I'm saying that this implies that he did not eat 10 apples. Negation E. Notice that this is the negation of my consequent as my second premise, and my conclusion is the negation of the antecedent. So this is Modus Tollens argument. And as I mentioned, the hypothetical syllogism argument is really easy to identify because I'll see two conditionals. There's the first one, and here's the second one. If Fred eats 10 apples, then he will get sick. If he gets sick, he will have to go to the hospital. So what I've got here is I've got E conditional S and S conditional H. And I'm saying that this implies if Fred eats 10 apples, then he will have to go to the hospital. In other words, my middle letter, the one that's the same, is gone, leaving me only with my first antecedent and my second consequent as my conclusion. So these modus ponens, modus tollens, and hypothetical syllogism arguments are the arguments that we're going to see extensively in the next couple of weeks. And so students really need to be able to recognize them, both symbolically and in the English statements. We'll talk more about this in our later lectures. For now, though, students really need to know these modus ponens, modus tollens, hypothetical syllogisms for the next couple of lessons. It's essential that those terms be memorized. So once again, this is Mr. Potter. Thank you for watching my video. See you next time.